Dear students, in this lecture, we will do the implementation of filters, FIR filter and IIR filter. FIR stands for Finite Impulse Response Filter and IIR stands for Infinite Impulse Response Filter. You have to draw the structure of the filter. The given is a differential equation. Then you will break this differential equation into smaller pieces, and based on that part you will draw the block diagram of the filter or block diagram or structure of the filter. Realization method of digital filters are direct form structure, cascade form structure, parallel form structure. And to draw the block diagram, the blocks are like this adder block. This is the symbol of this adder block. This is the symbol of adder. The other blocks are summing device. This is the symbol of summing device. Constant multiplier. This is the symbol of constant multiplier. Delay by k samples. You have to write z raised to power minus k. And advance by k samples. You have to write z raised to power k. Now what are the advantages of this block diagram? You know, from equation it is difficult to understand the structure, but from block diagram you can easily understand the structure. First is complexity of the structure is less. The first point given is just by observing the block diagram the computational algorithm can be easily written. Clear? The second is from the block diagram the relationship between from the block diagram the relationship between input and input are determined. The memory requirements and the computational complexity can be determined by block diagram structure. From the transfer function, variety of equivalent block diagram representations can be determined. Means there are various advantages to draw the block diagram of the filter. The other term that is used in structure of FIR filter or IIR filter are canonic and non-canonic structures. Canonic structures are those structures in which the number of delay elements are equal to the order of differential equation, that are canonic structures. Next is types of FIR structure: direct form structure, cascade form structure, and lattice form structure. First we will do direct form structure. See the direct form structure. Here the input is x of n and the output is y of n. The structure is drawn using delay element, using constant multiplier, using summer circuit. Then delay element, constant multiplier, summer circuit. See in this, always a delay element is represented by z raised to power minus 1. If you want x of n minus 1, matlab delay a sample by delay the circuit or delay the equation by 2 samples, then you will use 2 delay elements. For x of n minus 3 means 3 delay elements. Clear? What are the observations of direct form realization? There are m minus 1 delay blocks. The input signal is delayed m minus 1 times. So to store this delay input signal, m minus 1 memory locations are required. The structure has m minus 1 additions and m multiplications. Okay? Multiplication means this signal is constant multiplier is multiplication. Okay? Delay is memory elements. So from the structure you can observe these points. Clear? This is the structure of direct form of FIR filter. Next we will do the example of FIR filter. Direct form. See, you have given the equation of differential equation and you have to draw the block diagram, direct form structure of the this equation. Clear? See how you will find that is the differential equation is for FIR or for IIR filter, because these three forms are also available in IIR filter. If the numerical is given, that you have to draw the cascade form and parallel form, lattice form structure of this equation. How you will find that is this equation is for FIR or this is equation is for IIR. The difference between FIR and IIR is FIR filters are called recursive filters. Recursive filters means there is no feedback, but IIR filters are called non-recursive filters. Non-recursive filter means there is a feedback. So in FIR equation there will be no feedback. Feedback means signal coming from output side, and output is y of n. If in the equation the signal is coming from output side, mean in the equation you have the terms y of n minus 1, y of n minus 2, y of n plus 1, y of n minus 2, then the equation is IIR because there is a feedback given. If in the equation no term of y of n minus 1 or y of n plus 1 and so on, then the equation is for FIR filter. See, in this equation there is no term that is related to the output. Output is y of n. In the equation only the input and the delayed version of the input signal is given. The first step to draw the structure of the filter is to take the Z transform of the differential equation. We know the Z transform of y of n is y of z. The Z transform of this x of n is x of z. Z transform of x of n minus 1 is z raised to power minus 1 into x of z. X of n minus 2, Z transform is z raised to power minus 2 into x of z, and Z transform of x of n minus 3 will be z raised to power minus 3 into x of z. Similarly, Z transform of x of n minus 4 will be z raised to power minus 4 into x of z. Okay. From this, you will draw the structure. See, here the input is x of z and the output is y of z. Okay. First, x of z as such coming from the input signal, then it is adding with 2 z inverse x of z, means here the signal will be x into z inverse x of z into z inverse. Clear? It is multiplying by 2 because this is the symbol of constant multiplier, and it is added with this x of z. Clear? Then this signal is added with minus 3 z raised to power minus 2 into x of z. So from here there are two delays, means the signal available here is x of z into z raised to power minus 2, and this is multiplied by minus 3, so it is added with the previous equation. Similarly for this, here the signal available is z raised to power minus 3, it is multiplied by minus 4 and it is added with the previous. Then z raised to power minus 4, one more delay, it will be z raised to power minus 4 into x of z is also coming from the input side. Then this is multiplied by 5 and it is added with previous, so you will find y of z. So this is the direct form structure of FIR filter. Clear? What was the observation? M-1 delay elements are there, M multiplications are there, and so on. Clear? Next, we will do cascade form of FIR filter. In cascade form, H of Z is divided into H1 of Z into H2 of Z. means h of z is break into h1 of z multiply by h2 of z. Clear? h2 of z and so on. You can break like this. Okay, h1 of z, then h2 of z, and it can be up to hk of z. Then you will draw the direct form structure of h1 of z, h2 of z, and so on. The output of first will be the input of second. This is your cascade form of FIR filter. Next we will do the numerical of cascade form. Okay, the h of z given is 1 plus 5 by 2 z inverse plus 2 z raised to power minus 2 plus 2 z raised to power minus 3. Here this is, you can say x of z is the input, y of z is the output, and here the center using w of z. Clear? Now to break h of z into h1 of z into h2 of z means you have to factorize this equation. Okay, so by factorizing this equation we find this h1 of z into h2 of z term should be there. Okay, it can be more than h2 or so on. Okay, so you factorized this. Okay, this is the factorization of h of z. So assume the first part as h1 of z, you assume this, and h2 of z you assume this. First for h1 of z you draw the direct form structure. Clear? Now here it is z, h of z, it is equal to w of z. Transfer function is output upon input. For this h1 of z, output is w of z and input is x of z. So I write here w of z upon x of z is equal to this. Okay. Then w of z is equal to, if you cross multiply this, w of z is equal to x of z plus 2 into x of z, means you have cross multiplied this. Okay, this is divided by 1. Now we know output of first block is w of z and input of first block is x of z. Okay, w of z is equal to x of z. Okay, multiplying with 1 and it is added with delay of one element, मतलब z inverse. यहाँ पे सिग्नल क्या होगा आपका z inverse into x of z, then it is multiplied by 2. ठीक है, then it is multiplied by 2 and then it is added. ठीक है, this equation is direct form structure of this equation is this. This is your h1 of z. Clear? Now you will do the same for h2 of z. You will do the same for h2 of z. Clear? h2 of z is equals to this. h2 of z, it is written as y of z upon, here the output is y of z and the input is w of z, and this is equals to this equation. ठीक है, if you cross multiply it, then y of z comes out to be w of z, ठीक है, plus 1 by 2 z inverse w of z plus z raised to power minus 2 w of z. ठीक है, now you will draw the structure of this equation. What will be the structure of this equation? sorry. Okay, what will be the structure of this equation? Here is y of z, clear, that is equal to w of z 1 by 2 z inverse of w of z plus w of z 1 by 2 z inverse of w of z plus z inverse of w of z. Okay, now this is h1 of z. Now you will draw h2 of z. Here it is y of z and the input is w of z. Okay, w of z, then there is a, here you will write w of z. Okay, then w of z coming directly added with the word z inverse. Here is the block, you will write z inverse, clear, it is multiplied with 1 by 2, then it is added, then the again is z inverse. Okay, again is z inverse. Here you will find z raised to minus 2. Here it is z inverse, clear, then it is multiplied with 1 and added with previous equation. Okay, this, so you will get here y of z. Okay, this is the structure of, you will get here y of z. So this is the structure of, this is the structure of h2 of z. Okay, direct form structure, or this is the structure of h1 of z. Clear, this is the structure of h1 of z. In cascade form you have to combine the structure of h1 of z and h2 of z. Means the output of h1 of z will be the input of h2 of z. So this is combined with this. Clear, it is w of z, it is z inverse, it is also z inverse. Clear, this was the, I have covered the two structures, direct form structure of FIR filter and cascade form structure of FIR filter. In next we will do the lattice form structure of FIR filter. Thank you.